Welcome back. So let's now talk a little bit about read performance in MongoDB, why something called indexes are so important, and how we can actually create them ourselves. And I want to start this demonstration about indexes by firing off a simple query on all our tours. So let's come here to get all tours, and I will also filter for a price less than 1,000. Okay. And so let's see. Yeah, so we get 3 results back. All right. And that's important to keep in mind for what I'm going to show you next, which is that we can actually also get a couple of statistics about the query itself. So let's go here basically to the handler function. And so that is, remember, right now in the handler factory, right? So it's this, I think it's at the bottom. Yeah, so it's this get all factory function that will create this handler that is called for the query that we just performed. And so here on the query, I will actually now add an explain method. Okay, so after the query, we will then call explain, all right? And so let's take a look at that. And so we now get a completely different result, which is basically these statistics. Now there's a lot of stuff in here, but what I'm really interested in is these execution statistics. Okay, so we can see here that the number of documents that were returned were 3. And so that's exactly the result that we got before. So before doing the explain, right? But what's really important to note here is that the number of documents that were examined is 9. Okay? And so this means that MongoDB had to examine, so basically to scan all of the 9 documents in order to find the correct 3 ones. So the 3 ones that match the query. Okay? And so that's not efficient at all, right? Now, of course, at this scale, with only 9 documents, it makes absolutely no difference. But if we had hundreds of thousands or even millions of documents here, then this would significantly affect the read performance of this query. So again, it's not going to be the case in this application, but it might be in an app that you will build someday. And so you really need to learn about indexes, because with indexes, we will be able to kind of solve this problem. So we can create indexes on specific fields in a collection. For example, Mongo automatically creates an index on the ID field by default. And let's actually see that in Compass. Okay, for example, in our tours, we have here the indexes tab. So up until this point, we only ever were here in the documents tab, but as you see, we have a lot of different stuff here, and one of them is the indexes. And so again, you see that here by default, we have an ID index. And this ID index is then basically an ordered list of all the IDs that get stored somewhere outside of the collection. Okay, and you can actually see the size here, that it has 36 kilobytes, this index, right? And this index is extremely useful, because whenever documents are queried by the ID, MongoDB will search that ordered index instead of searching through the whole collection and look at all the documents one by one, which is, of course, much slower. So, again, without an index, Mongo has to look at each document one by one. But with an index on a field that we are querying for, this process becomes much more efficient. So that is pretty smart, right? And of course, we can set our own indexes on fields that we query very often. So let's actually do that with the price field that we just queried for before, because I believe that it is one of the most important that people will query for. Okay? And so this is how it works. So we need to go to the tour model, right? And then let's do it right here after the schema declaration. And we say tour schema dot index. Okay, and then an object with the name of the field. And remember how we said we were going to set the index on the price, and then either a 1 or a -1. And 1 means that we're sorting the price index in an ascending order, while the -1 stands for descending order. Okay? And there are actually other types of indexes as well, like for text or for geospatial data, but we will see that a bit later. Okay, so let's give it a save now and try our query again. And actually I will do it a couple of times here to make sure that the index is really set, because sometimes it is not set like right away. But let's now take a look here. And so indeed, we get still our number of returned is 3, but this time the number of documents that were examined, so that were scanned, were also only 3. And so that proves that with this index, we basically achieved exactly what we wanted. So before we had to scan through all of the 9 documents, and now the engine only needs to scan the 3 documents that are actually also returned. And again, because their prices are now ordered in that index. And so that makes it much easier and much faster for the MongoDB engine to find them. And so this is, of course, a huge performance gain. Let's now also check out Compass here. And actually, let's reload the entire database. And now it should actually be here. But for some reason, it's not. Let's maybe try to reload the documents. Maybe it appears then. Not really. Let's also analyze the schema. And that's something that we're going to talk about a bit later. But still, as you see, we still only have these 2 indexes. But that doesn't matter at all, because we already know that the index is actually working, right? So it's completely normal that sometimes this takes some time to update. Now, another thing that you might notice here is how this ID index that we talked about earlier says unique here, okay? And so unique is also a property that we can give to indexes. And this is actually the reason why the IDs have always to be unique. So simply because the index of the ID has this unique property. You probably also noticed that there is an index for the name here, right? But we didn't actually create that manually ourselves, right? So can you guess why it is here? Well, it is because in our schema definition, we set the name field to be unique. And so what Mongoose then does behind the scenes in order to ensure the uniqueness of this field is to create a unique index for it, all right? And so because of that, not only the ID, but also the name always have to be unique. Okay, and this is great already. So when all we ever do is to just query for one single field alone, then a single field index is perfect. Because remember, the index that we just set before is called a single field index. Not sure if I mentioned it back then, but I think I did. But anyway, if we sometimes query for that field, but combined with another one, then it's actually more efficient to create a compound index. So one with 2 fields and not just one. So let's create a query for that just to illustrate it. And so another field that I think is going to be queried for all the time is the ratings average. So ratings average, I think that's how it's called. And let's say that we want greater or equal than 4.7. Okay, let's send that query. And let's see how many results we get. And where is that? Yeah, here. So the number of results, so the number of documents that are returned, so that match this query, is 2. But we still had to examine 3 documents. And again, at this scale, of course, that doesn't make any difference. But as you understand, this is just an example. And so we now want to fix this situation as well. And for that, we're going to use a compound index. So let's go back here, comment this one out, or actually first duplicate it and then comment. And so it's actually very simple. All we need to do is to add here the other field. So ratings average, and let's put this one in the ascending order. Or actually that's the descending order. All right, so let's give this a save. Let's go back here. And again, I'm going to do it a couple of times here. Okay, and let's see our results. And so now we get the result that we wanted. So only 2 documents were scanned in order to find the 2 documents that we were actually looking for. Perfect. And actually, this compound index that we just created is also going to work when we query for just one of these two fields here individually, so price or ratings average. So when we create a compound index like this, we do not have to then create one individual for each of the fields as well, okay? I just want to check out how it looks in Compass now. But well, it still looks the same. But again, not really important. One thing that we can still see here, and which is pretty interesting, is that actually the size of these indexes, so 72 kilobytes, is actually way bigger than the total size of all the documents combined, which is only 14 kilobyte, right? And so basically, these indexes that we create to search the documents take up a lot more space than the documents themselves. But again, that's just because we're operating on such a small scale in this example. And so that's not really relevant. Okay, but it's still important to talk about this because actually this leads me to our next question. And that question is, how do we decide which field we actually need to index? And why don't we set indexes on all the fields? Well, we kind of used the strategy that I used to set the indexes on the price and on the average rating. So basically, we need to carefully study the access patterns of our application in order to figure out which fields are queried the most and then set the indexes for these fields. For example, I'm not setting an index here on the group size because I don't really believe that many people will query for that parameter. And so I don't need to create an index there because we really do not want to overdo it with indexes. So we don't want to blindly set indexes on all the fields and then hope for the best, basically. And the reason for that is that each index actually uses resources. So as you can actually see here, right? And also, each index needs to be updated each time that the underlying collection is updated. So if you have a collection with a high write-read ratio, so a collection that is mostly written to, then it would make absolutely no sense to create an index on any field in this collection, because the cost of always updating the index and keeping it in memory clearly outweighs the benefit of having the index in the first place if we rarely have searches, so have queries for that collection. So in summary, when deciding whether to index a certain field or not, we must kind of balance the frequency of queries using that exact field with the cost of maintaining this index, and also with the read-write pattern of the resource. However, just like it is with data modeling, there are not really hard rules here. So it's all a bit fuzzy, and you really need some experimentation and also experience to get it right. Alright? But whatever you do, please don't just ignore indexing, because even if it's not perfect, it will always have a huge benefit for your application. Alright. And that's actually all I had to tell you about indexes. There's just one more index that I actually want to set here, which is for the tour slug, okay? Because later on, we will actually want to use the unique slug to query for tours. So meaning that the slug will then probably become the most queried field. And so it makes all the sense to also have an index for that one. So tour schema.index and slug 1. And most times, the 1 or -1 is not that important. Okay. Now I'm really curious to try to see this here in Compass. So what I'm going to do is to try to connect to the database again here. And so I can just get that here from the most recent ones. Click connect, and then we should get connected to the same database. So naders, tours, let's come to our indexes. And now here we go. So now we actually have our indexes right here. So let's make this window bigger and take a look at what we got. So we have our slug here, right? We have the price, which is the first one that we set. And then we also have the price and ratings average, which is compound. And you also see here that this one here is ascending and this one is descending because it has the -1. And another thing you might notice is that actually we no longer have this price index in our code, but it's still here. And so it's not enough to remove the index from our code. We really need to delete it from the database itself, right? So remember, we had it here in the beginning, and then we commented it out and created this new compound index. But again, the index is then still here. But since we actually no longer need it, we can just go ahead and delete it. Okay, now we need to type the name just to make sure that we do not do any mistakes. And so here we go. Great. So that is the power of indexes. They really can make our read performance on databases much, much better. And so in your own applications, you should really never ignore them. Oh, and before we finish, let's actually take back that explain method that we added here in our handler function. And actually, just as a reference, I will leave it here like this. Okay. Give it a save. Back in Postman. Let's try that now. And indeed, it's back to working. Okay, and now that's really it.